Let's work on solving some logarithmic equations and exponential equations. We'll actually use this fundamental identity over and over again. If y equals a to the x, that can be rewritten as x equals log base a of y. So these are two different ways of saying the same thing because exponents and logs are inverses of each other. So if you have a basic equation like one of these that has fundamentally three pieces, how do I mean three pieces? Well, it has an input, it has a base, and it has an output. Okay? What happens here is I can convert that to a log equation as follows. Log base 2 of 3x equals y. Similarly, down here, this has fundamentally three pieces. It has a base, input, and output. The inputs and the outputs switch for exponential functions. 2 to the 4 plus y equals 7t. Notice this entire piece plays the role of the output here and the input here. These get more complicated when they're not basic exponential or logarithmic equations. Notice this has other pieces, so I have to convert it to a basic form of the equation before I can start. First, I'll add 4 to both sides. Then I'll divide by 5. Can you see that I now have the three fundamental pieces? I have a base, a power or input, and an output. Okay, now I can convert it to a logarithmic equation. Since the base is e, remember, you might think log base e, but log base e of x gets written natural log of x. So this is natural log of 4/5 equals 3t. Now this problem didn't say to do it, but you can see here you could really easily solve for t if you needed to. Here it would have been hard to solve for t. Okay, last, how do I deal with something like this? This is not a basic logarithmic function. It doesn't have the three pieces. I'm going to have to combine these two. I'm going to use a log property. So 0 equals log base 2 of x over 5 minus 8. I've used a log property. Now I'm going to pull the 8 over to the other side. Now I have the three fundamental pieces, base, input, output. I'll convert it to an exponential equation. 2 to the 8 equals x over 5. Again, I've solved this problem, but you can see how this would be really useful down the road to solve for x.